Welcome to this new section of trigonometric measurement, and this is specifically paper 2 work, so we are now moving away from the paper 1 work that we did in differential calculus and we're going back to paper 2, specifically trigonometry, but looking at measurement of triangles and also in this case 3D measurement, which is the next section we're going to get to. Okay, right, before we can get to the grade 12 work, we first have to do revision of the grade 11 work. So in the revision of the grade 11 work, we pretty much just refer again to the sine rule, the cosine rule, and the area rule. So let's get started. Right, now the sine rule says in any triangle, not necessarily a 90-degree triangle, by the way, you can use the sine rule and the cosine rule in a 90-degree triangle as well, but specifically any triangle. So in any triangle, you can say that there's a ratio between the sine of an angle and the side opposite that angle. And this ratio remains constant in that triangle. So pretty much what it says is it says that sine of angle A over A, so that ratio of the sine of the angle over the opposite side, will be equal to the sine of angle B over side B. So that sine of the angle B over the opposite side, which will then also be equal to the sine of angle C over side C. And we can obviously go and we can write the reciprocals down by just saying the side over the sine of the angle are then also equal. So that just gives me a constant ratio in every triangle, and you can then go and you can use this constant ratio in every triangle to then go and calculate whatever they ask for, be it calculate an angle, be it calculate a side. So we can do a bunch of little examples, but like I said, this should all seem fairly familiar to you guys because all of this was done last year. Right, now the sine rule specifically is used under the following circumstances. The first one is when they give you two sides and an excluded angle in a triangle. So in this triangle, they've given you this side 5 meters, this side 6 meters, and then they've given you an excluded angle, excluded meaning it is not included between the two given sides, it is outside those two given sides. Then we can use the sine rule. So we can then in this triangle go and say, and by the way, what they would normally ask for here is they would ask you to calculate an angle. So if they give you two sides and an excluded angle, they would then go and ask you to calculate another angle. So we can, for instance, go and we can say, let's call this angle theta, and that's what we are trying to calculate. So we're going to say the sine of angle theta over the side opposite to it, which is 6, is going to be the sine of 55 degrees over the side opposite to it, which is then 5. And then very simply we can calculate that quite easily by saying it's sine 55 degrees over 5, which we are then going to multiply by 6, and that's then going to give us the sine of theta, which is 0.9829, not rounded off yet, and then to get that angle we're just going to work with the inverse of sine. So we go shift, inverse of sine of that particular answer, and then we get theta in this case, correct to 1 decimal place, is 79.4 degrees. So very simple, straightforward, to use that sine rule to calculate a missing angle if you have two sides and very specifically an excluded angle. Now, the sine rule also works if you have two angles and an excluded side. So in this case, they've given you these two angles, the 52 degrees and the 65 degrees, and they've given you a side. And then they will go and they will require, for instance, for you to work out this side. Let's say this side is x. And you can then work out this side by simply saying it's x over the sine of 65 degrees is then equal to the other known side, which is 8, over the sine of the angle opposite to it. So it's the sine of 52 degrees. And this one is pretty easy and straightforward. We can then just go and multiply this by that denominator. So we can say 8 times the sine of 65 divided then by the sine of 52. And my answer there is going to be correct to 1 decimal place, 9.2, and our units are in centimeters. So that's the second situation in which I can use the sine rule. Then there's actually a third situation in which we can use the sine rule. And this situation is not initially very obvious, but it becomes obvious if you take one small thing into account. You can also use the sine rule where you have two angles and an included side. So if you have two angles and an included side, technically speaking, the sine rule doesn't work for this information. But because you have those two angles, it allows you to calculate the third angle first. So we're going to put a little asterisk next to this one because, yes, you can use it with the two sides and an included angle, but before you do anything else, you have to use sum of angles of a triangle. So we will use sum of angles of a triangle to calculate this missing side, that missing angle right there. So I'll simply go and say it's 180 degrees minus 63 minus 54, which is then going to be 63 degrees. So that one I can calculate and say that's 63 degrees. And the moment I've got that 63 degrees, I can then again go and use my sine rule here, because now I can ignore one of those two angles, and I can say now instead of having two angles and an included side, I now have two angles and an excluded side. So that pretty much just goes back to the previous technique. Very simple and straightforward. Just going to see if I can fix this focus. That's a little bit better. Okay, right. So in this case, they might have gone and said, okay, please go and calculate this one being x. And that is why, because we want to calculate this one, we are then going to be ignoring this angle, because I need to go and say it's the side over the sine of the 54 degrees, which is the angle opposite to it, is then going to be equal to 15 over the sine of the angle opposite to it. And that's why I had to calculate that 63 degrees. And again, I can just type it into my calculator, and I can say it's 15 times the sine of 54 divided by the sine of 63. And that is then going to be equal to 13,6, and the units here is millimeter. So that's pretty much the sine rule. That's how you use the sine rule. Now I do need to go and mention that the sine rule has something called the ambiguous case. And I'm sure your teacher taught you last year about the ambiguous case, but hopefully they also mentioned that the ambiguous case is not something that often happens. And if it does happen, they generally try and scaffold it slightly just to go and indicate that there's more than one option here. There's more than one value that you can calculate. So please watch out for any type of clue that it's the ambiguous case, where instead of just saying calculate the value of the side, they say calculate the values, and where they put that little S in brackets. So if they say something like that, you might want to think this could potentially be the ambiguous case. Okay, now when do we use the ambiguous case? It happens when two sides and an excluded angle is given. So that is the sine rule. But the angle opposite the shortest side is given. So the one angle that they give you is not opposite the bigger of the two sides, it's opposite the shorter of the two sides. If they'd given you this angle, this wouldn't have been a problem. But because they give you this angle, you need to take the following into account, because there are two possible triangles that can actually form here. This is the first triangle that can form, and the second triangle that could form is the following. It's possible, using this exact same information, that that 2,5 centimeters was over there. So that means we could have one triangle like this, where this angle over here specifically is going to be an acute angle. But it's also possible to have this triangle, which is exactly the same information if you think about it. But that means that instead of having the acute angle over here, we now have an obtuse angle. So that's the only thing you have to take into account with this particular ambiguous case. So in this ambiguous case, because we've got the two sides and the excluded angle, we are then going to have to go and calculate that missing angle. So like I said, the angle could have been here, this could have been theta, or this potentially could have been theta. Okay, so I know I'm not really supposed to call that one theta, just simply because they can't have the same value, so let's rather go and call this one alpha. So it's possible that the triangle could have looked like this and you had had to calculate theta, the acute angle, or it's possible that the triangle looks like that and you had to calculate alpha, the obtuse angle. So very simple and straightforward using the sine rule. We're again going to say the sine of theta over the side opposite to it, which is the 4 centimeters, is then equal to the sine of 32 degrees opposite the side, over the side opposite to it, which is the 2,5. We can then go and we can calculate theta, but first we're just going to write down sine theta is equal to, and we're going to say it's 4 times that sine of 32 over then the 2,5. And we get that ratio of 0,8478 ... And then we use shift inverse sine function of that previous answer, and we say theta is then equal to 57,98. So if I round that off to one decimal place, that's actually going to be 58 degrees. Sorry about that, 58 degrees. Let's just clean that up. So that's going to be 58 degrees. But, as I explained, it could have been this angle, which is 58 degrees, or it's possible that it was this angle. Now, the reason it's also possible is the following. If you think about it, sine of an angle has a positive ratio, not only in the first quadrant, meaning an angle between 0 and 90, but it also has a positive ratio in the second quadrant, which is an angle between 90 and 180 degrees. So that's why you could have calculated alpha by saying it's 180 degrees minus that 58 degrees. Here we go. Which is then equal to 122 degrees. But like I said, this part right here will only happen in the ambiguous cases part, and you will only do it under the following circumstances. And in all honesty, I have only about once or twice seen the ambiguous case asked in a matric final exam paper. So be aware of it, but unless they scaffold and they clearly state calculate the 2 possible angles or the 2 possible sides, you can actually go and skip the ambiguous case. Okay, not skip as in not learn it, but not take it too seriously. Right. Now, next rule we have to look at, revision of grade 11, is my cosine rule. Now my cosine rule is not exactly as easy to use as the sine rule, but luckily they do give it to you on the formula sheet where they say side a squared is equal to b squared, so side b squared plus side c squared minus 2 times side b times side c times then the cos, and this is very important, whatever side I use over here, I have to go and have the cos of the angle opposite that side. So it's the cos of A. There you go. Okay. Now, obviously this is the only variation of this they give to you on your formula sheet, but you can adjust it as you see fit. But there's one very important adjustment that you also have to take into account. And that important adjustment, quite often they ask you in step 1 of a sum to first go and say, write cos A as the subject of the formula here. So I'm just quickly going to do this because we do need it for one of the circumstances where they go and you have to use the cosine rule. We'll talk about that just now. But first we're just going to go and say, I can make cos of A the subject of the formula by saying, this is 2bc times the cos of A, which is then going to be equal to b squared plus c squared minus a squared. There you go. And then finally, I can just divide both sides by that 2bc. So pretty straightforward and easy adjustment, but like I said, I'm going to put an asterisk next to this. This is not on your formula sheet. You have to be able to do this adjustment on your own should you need it. Okay, now when do we use the cosine rule? We use the cosine rule again when the following is given. If they give me 2 sides and an included angle. Now this situation we did not discuss in the sine rule. As you could see, with the sine rule we said over here, that it works if I have two sides and an excluded angle. But the moment I've got two sides and an included angle, the sine rule does not work. I cannot use the sine rule. I have to, in this case, use the cosine rule. So using this formula, very, very easy, I will always go and say, oh, by the way, when they give you two sides and an included angle, what they normally want you to calculate is they want you to go and calculate the third side. So in this case, we can say x. So we can say this side, x squared, is then equal to, and then using my formula, I will always go and use those two sides that include the angle. That's what this formula says. So I will use the one side 4 squared plus 7 squared minus 2, and then I use these two sides again, 4 times 7. And then very important, it's the cos of the included side, which is also the angle opposite, sorry, not the included side, the included angle. It's the cos of the included angle, which is then specifically the angle opposite that side that I want to calculate. So the cos of 72 degrees. Now, when I type this in, be very careful because this is a very common mistake. I go 4 squared plus 7 squared minus 2 times 4 times 7, and then cos of 72. And that very common mistake, two common mistakes actually. Number one, a lot of people, they don't think about it for a split second, and then instead of typing in cos of 72, they type in the sine of 72. So please watch that one. Now they get an answer and they say, answer is 47,695 ... And they think they're done. You're not done. Because this is not what x is equal to, this is what x squared is equal to. So I still need to go and work out the square root of that answer. So that means x, correct to 1 decimal place, is 6,9, and the units is centimeter. So very easy and straightforward to use it. Now, this is why I did this adjustment of the cosine formula up here. The adjustment was specifically done to refer to this situation in which I use my cosine rule. And this particular situation is where three sides are given. So when three sides are given, instead of using it as is, I'm going to use this version. And this version, very straightforward, depending obviously on what angle I want to calculate. So let's say you want to calculate this one. You want to calculate that one, and I'm going to call it theta. So I want to go and calculate theta, so I'm going to say it's the cos of theta. Now watch how you use it, because these first two sides that are right there cannot be the side opposite the angle. The side opposite the angle, that one, must always go last. So just watch that very carefully. So I will first take these two and say it's 3 squared plus 5 squared minus then that's 6 squared. So just watch what I've done over here. I've said if I want to work out the cos of an angle, whatever side is opposite that angle always gets used last there. And the two sides that include that angle, those two sides are the ones that I'm going to use in these positions. So because this angle is included between that 3 and 5, that's why I say 3 squared and 5 squared, and that's also why I say 2 times 3 times 5. And then again, I can go and work this out. So it's going to be 3 squared plus 5 squared minus 6 squared over 2 times 3 times 5. There you go. And that's going to mean that the cos of theta is equal to negative 1 over 15. And then I can go shift inverse of cos of that answer, and I end up with theta being equal to 93,8 degrees, correct to 1 decimal place. So pretty easy and straightforward. Fortunately, this diagram isn't very accurate, but hopefully you get the idea. Right. Then one last little rule we have to talk about to finish up with this grade 11 revision, and that is the area rule. Now the area rule states that the area of any triangle, in this case triangle ABC, is going to be equal to half, and now you can pick any two sides. So I can pick side A and side B. So it's half side A times side B times the sine, and very important, this must always be the included angle. So if I've picked side A and B, it's got to be the sine of angle C. And you can adjust that. You can say it's half B times C times the sine of angle A. Or you could say it's half A times C times the sine of angle B. So any of those ones, but please remember it's two sides and an included angle for this formula. Don't confuse those two sides and an included angle with a cosine rule, because cosine rule is obviously used to work out another side, whereas this formula is specifically used to work out the area. And that is why you use this particular formula either when the area is asked or when the area is given. So only when they mention area do you use the area formula. If area is not mentioned, you either use the sine rule or you use the cosine rule. So in this case, they will ask you calculate the area of this triangle. And when they ask you calculate the area of this triangle, we will say the area of this triangle is half the one side, 7,5, times the other side, which is 9, times the sine of the included angle, which is 40 degrees. And you can type that straight into your calculator. Sine of 40, and then your answer is then 21,7, and be very careful, this one is centimeters, but it's got to be centimeters squared because I'm calculating the area there. And that is pretty much the entire video on that revision of the grade 11 content, because it's very important that you remember all of this stuff, because all of this stuff is now going to be used for the grade 12 content, but all of these rules are now going to be used in 3 dimensions. So the next video will talk about using all of these formulas in 3 dimensions. Thank you.